Today what I'm going to present is the MATLAB assignment on the design of a third-order transfer function based on system identification and Simulink simulation. Next, I will introduce the assignment requirements, the completion process, and the final results in sequence. This video is divided into 5 parts, namely main content, thoughts on system modeling and identification, building of Simulink simulation model, PID controller parameter settings, presentation of simulation results. This is the part 1 main content. My homework is to design a third-order transfer function using system identification, then simulate it in Simulink via MATLAB, choosing either a rotational or linear system model. This is part 3, thoughts on system. This is part 2, thoughts on system modeling and identification. First of all, system modeling and identification needs to be carried out. I obtained the input-output data of the system through experiments or data connection. Then, by using system identification algorithms such as the least squares method, I finally got the third-order transfer function. Is this G of S equals 523,500 divided by S to the power of 3 plus 87.35 times as squared plus 10,470 times S, which is the system model I'm going to simulate. This is the part 3 construction of Simulink simulation model. Next, I build the simulation model in Simulink. Please look at this diagram. The scepter block provides the input. The summation block calculates the difference between the feedback signal and the input signal. Provide error to the PID controller. The PID controller performs proportional, integral, and derivative operations based on the area, and the parameters will be described in detail later. The transfer function. The transfer function block is the third order system I just obtained. The oscilloscope is used to observe the output response. With the cooperation of each model, the system operation can be simulated. This is the part 4, PID controller parameter settings. Now look at the parameter settings of the PID controller. The proportional coefficient P is set to 0.8. The I is 0.03 and the D is 0.01 and the N is 100. Additionally, there is a term between or divisible. With the help of the Simulink control design tool, the games can be adjusted automatically. However, this time I use those parameters manually. This is the part 5, precipitation of Simulink resource. After running the simulation, the result shown on the oscilloscope is as follows. Under the set input and the output of the system has a brief oscillation at the beginning, and then gradually stabilize near the target wheel. This indicates that the PID controller asset works quite well for this third-order system. Next, I will demonstrate the model building process again. Let me open the MATLAB and the Simulink. Okay, I open a new project and then this one. And the output is scoop. This one. And need more one for there. And then found the this one. And then the transfer function. This one. The number I use is 523 500. And then is 1. The next is 78.35. And then it's 10470. Oh, there. And then it's there. Okay. And then of the PID controller. This one. Okay. First one is this one. Okay, and then PID transfer function and output. Okay, the next is there and before input and okay, and the data is for PID. The P is 0.8, I is 0.03, and the D 0.01. Okay, and the time I use 5. Okay, and then this is the output. Okay. The thing. My explanation is over. Thank you for everyone.